Do you know that banks detect fraud in real time within milliseconds before the damage is done? And the best part, you can also build your own fraud detection system using Apache Kafka and Redis. Today I'll show you how to do it. By the end of this video, you'll have a working real-time fraud detection system that processes transactions, detects fraud, and sends instant alerts. Let's dive in. Overall, we will implement 3 fraud detection rules. First one is large transaction amount, second is multiple rapid transactions, and third one will be location changes. Alright, so we'll start with the actual high level architecture diagram, that is this one. I hope you guys can see clearly. Okay, so the request first comes from client to transaction service. Transaction service consumes the request as a REST API and basically just sends a transaction record into the transactions topic inside the Kafka. Okay, now fraud detection service. So in this case, transaction service acts as a producer for this topic transactions. Okay, now we have other service, that is fraud detection service. If I can maybe use laser. Okay, the other service is fraud detection service. This service acts as a Kafka consumer and it will consume all the messages from transactions topic. So whatever the messages that transaction service puts in into the transactions topic, fraud detection service will consume those messages and try to identify if there are any patterns for fraud. That's it. Okay. If at all, if this fraud detection service detects any fraud, it will send an alert message into the fraud alerts topic. And we have a separate independent service which is alert service, basically just consumes from these topics and assume that this alert service can send an email, SMS or an OTP just as an extra check or validation. Okay, and also if you see here, fraud detection service is also using Redis for this one. The reason we are using Redis is to store the last 5 transactions timestamps. As I mentioned earlier, one of the fraud detection rule is basically rapid transactions, right? And we'll try to detect at least if there are 5 recent transactions within a span of 30 seconds or 60 seconds. So in order to do that detection, we basically will store as a list in the Redis itself. Okay, and also transaction service will add a transaction event into a separate list which will store last 10 transactions that can be used for any other purposes, but as a demonstration I'm going to show that as well. I hope this architecture diagram is clear. Now let's move on to Docker Compose file where we define 3 services. Okay, if you look at the beginning, first we have the Kafka, and this time around we are using Apache Kafka, not the Bitnami Kafka, because due to some small environment variables issue and all, but there won't be much of a difference. So in this video we'll be just sticking to Apache Kafka based Kafka image. That's it. Okay, most of these environment variables we have been covering in all the previous videos, but if you're the new viewer, I would highly recommend to watch the Kafka fundamentals video. I'll share that in the description. Okay, to sum it up, if you see, we are using only one Kafka instance and the other one is Kafka UI. This is basically to look at the topics, consumers, messages and all that stuff. It's basically a simple UI tool. That's it. Okay, and over here we are not using any zookeeper because the latest Kafka does support controller mode also, that is we are using kraft. Also on the kraft I have a separate video, you guys can check it out. Overall, so if you see here, this important process roles, this will define this Kafka container will act as both broker and also controller. Broker as in basically the Kafka broker where you can store the topics and all that stuff, partitions, messages and all that stuff. Okay, controller is basically where it will manage the whole brokers. Right now we have only one broker setup, but in real world we'll be having 3 or 4 brokers based on the business logics and how you want to design. Okay, in simple terms, we are exposing the port to 9094 as an external port, and also we'll be using the name as Kafka itself. Okay, and rest of the environment variables are basically to set the default replication factor, number of partitions and all that stuff. This Kafka create topics is basically where it will create automatically when the server starts. Somehow this is not working, could be the non variable is not even working in the latest versions, but you guys can ignore this one because we'll manually create these if it's not created from the Kafka UI tool. That is basically next service, that is Kafka UI. We are using from the Project Labs and the port is listening at 8080. That's it. Okay, now here the most important part is this one, bootstrap servers. This we need to mention it as Kafka 9092. The reason is these two services run in the same network and that is being accessible with the domain name of this of the container, that is Kafka, right? Kafka colon 9092, which is basically how we are defining it as a listener port as plain text 9092. Simple. Okay, this is very important. If you mess this up, you basically Kafka UI doesn't load and it can't connect to the actual Kafka instance within this whole Docker setup. Okay, And also if you see depends on, we are clearly mentioning that we need Kafka instance. That's it. Okay. Now Redis also we are using Redis stack so that we'll get the UI part of it, and the UI part will be accessible at 8001 port. And we are having only one environment variable, that is Redis args. As you can see, we are passing require pass. This is basically the password we can provide. We need to pass this password when we connect. That's it. So overall we have only three services in the Docker Compose, that is Kafka, Kafka UI and Redis. And if you look at the architecture diagram, we have other services like the actual services: transaction service, fraud detection service, and alert service. So three services. These three services will run it from the terminal itself, just for the simplicity's sake. Okay. Now I'll just start with the transaction service. All right. Let me quickly see if I can minify all right. So if you look at the very high level, we are using crypto just to generate the UUID. We are using Express, Kafka JS for Kafka related stuff, and Redis. That's it. Okay. Now we are simply getting the Express. It's a very basic server. We are just getting the Express instance, and on top of it we are trying to get the Kafka instance. And this is where we are mentioning clearly that access the Kafka server is accessible at 9094 port. That's it. Okay. Now once we get this Kafka instance, we are trying to get the producer instance as well, and this is basically to support the legacy partitioner, but you guys can ignore this one. Overall, at this line we are trying to get the Kafka producer instance. Simple. And next we have this Redis client instance as well. Here we'll mention the URL. If you look at the URL format, usually it will be like mongodb colon slash slash username colon password at the rate domain name and port. In this Redis also it's the same syntax, just that the protocol is Redis colon. We don't have any username configured, so that's why right after the two forward slashes, instead of username as it's empty, we just start with the colon and we'll pass the password over here, that is can remember. This can remember, if you can recollect from the Docker Compose, that we define clearly over here. Require pass, this is the password what we defined. So we need to just use this to access Redis client. That's it. Okay. Now we have this main endpoint API v1 transactions. Okay. I'll just go through this one as well. We are trying to get these four fields: user ID, amount, currency, and location. Okay. And we are basically constructing the whole transaction record, and we are storing that in the Redis. If you see this notation, key is nothing but the in a simple way key value is stored, right? Redis. So key is nothing but the actual field name. So here we are trying to construct that as a user colon user ID colon transactions. So with this key we are trying to create a list. Okay. Now if you see L push, we are trying to push this string transaction record, converting that into string and pushing into this list that is named as key. This key will be this one, user colon user ID colon transaction. Simple. Okay. Now if you this specific step, this line 48 is very important. So what you're trying to do is, we're always trying to save the very last 10 transactions only. Overall, let's say 11 transactions happen, then the very first transaction will be removed with this line. Trimming, basically we're trying to trim and store only the 0 to 9. That's it. Okay. And this is basically push is basically in the reverse order. Okay. It's not like an array dot push. L push is basically inserts the record at the beginning of the list. So basically list is also termed as from left to right. Zero index will have the latest transaction. That's it. And you're trying to trim, so persist only from 0 to 9. So what are the transactions, if at all, if it comes with this line, we'll snap it to 10 transactions. Those are last 10, the very latest 10 transactions. That's it. Okay. Then this is a simple producer.send. This is a Kafka producer. We are trying to send this to transactions topic, and key is nothing but, as we'll be defining 10 partitions for this topic transactions, based on this key user ID, it will end up into specific partition only. And no matter what, how many times you send it with the same user ID, the message will always send to the same partition. That's the main crux of the Kafka. If you need to brush up more fundamental concepts on Kafka, I release many videos, so please go through those in the same playlist. Alright, and later I'm just trying to print it out and just sending this transaction ID for a reference as part of the response. That's it. Okay. And this init is basically trying to connect this. As we just created these instances, we need to connect this. So in the init function, we're just trying to connect the Kafka producer connect and Redis client connect. That's it. Simple. Okay. Before running this transaction service, we'll try to spin up the Docker container so that those are ready. So let's open terminal over here, and you can just simply call docker compose up-d. All right. All three services started. Let's look at the Docker desktop over here, and let's open few of the logs and see whether all instances are settled enough. Kafka UI. Okay, so before starting our transaction service, let's access Kafka with the Kafka UI tool, and that would be at 8080. We have one cluster accessible, that is local cluster, we just named it. And in the brokers, one broker we have instead of three broker setup for the simplicity sake. Okay, now if you look at the topics, we have 0. I think it's bit add topic is not visible, so I'll just minify it, and we can just click add topic, and we need to pass the topic name over here, and topic name in this case will be transactions. So transactions, and let's give oops, and let's give partitions as 10, and also 7 days as the retention time. Okay, simple. Transactions, create topic. And also if you look at the architecture diagram, we have another topic, so let's create this as well, fraud alerts. Now topics list, add topic, fraud alerts. Maybe for this time around we'll just give 5 partitions, 7 days, create topic, that's it. So overall if you see, we have two topics: transactions with 10 partitions, fraud alerts with 5 partitions. Replication factor is 1 because we have only one broker. Even if you try to create replication factor with 3, it doesn't work. Okay, simple. Now total and overall if you see, number of messages are 0 because we haven't even pushed anything. Simple. Okay, now let's run the transaction service. All right, so maybe over here, node transaction service. Okay, now transaction API running on port 3000. Server is up and running. Alright, now let's open Postman and send one request. Okay, user ID we are giving it as -0, and maybe we'll just call it as U01. Simple. Okay, this is simply the user ID. Amount is 5000, currency is INR, location is India. Okay, now just simply send. We got the response in 41 milliseconds, and this is the transaction ID. It's a random UUID. Okay, now let's look at the Kafka overall. And if you access over here, transactions, messages, we have one message. If you see key U01, and it came into partition 4. So no matter if you send multiple requests, it will always send into partition 4. We'll try with other user ID also, so that I can show you based on the key it will send, it might end up in different partition, because overall we have 10 partitions. If you see 0 to 9 partitions for this topic, transactions. Simple. Okay, now if you look at the architecture diagram, at this stage we cover this transaction service. We are sending a request, and transaction service actually pushing a message to transactions topic. Now let's move further and start this fraud detection service. Okay, and also we have this Redis also. I think we are pushing that. Let's look at that part. Let's open Redis as well. It's 8001, first time we are accessing, so let's accept some stuff and enter password. That would be can remember. That's it. Okay, apply changes. You can see now there is one list. The type is list over here, and the key is user:u01. This u01 is nothing but the user ID what we sent over here. Okay, and we have this key as user:u01 transaction. That's how we are pushing to the list. If you look at the pattern over here, store transaction history in Redis, last 10 transactions. Okay, I'll showcase this also. What if we send 11 transactions overall? Are we still storing only 10 or not? Okay, this is how we are trying to push. All right, now if you see here, this is the same value. If you look at the transaction IDs at the end, 0628. We can verify from the Postman as well. Okay, now I'll show you the fraud detection service definition, and we'll start that service as well. Till this part, if you found this video helpful, make sure you hit that like button and subscribe. Okay, this is also a simple Node.js script, and if you see, we have Kafka.js and Redis as an import modules, and over here new Kafka instance connecting with the client ID as fraud detection consumer. Simple. And this is basically where the Kafka instance is running, localhost 9094. And the consumer, if you see for the consumer instance, we clearly mention it as group ID fraud detection group. That's it. Okay, and producer instance is same, and Redis client instance is also similar. Okay, now if you look at the consumer transactions, this is the entry point, consume transactions. Okay, now this is also similar to init consumer, Kafka consumer connect, where we are trying to establish a connection, consumer subscribe. So we are subscribing. So this line, basically line 20, will clearly tell that subscribe to topic transactions, and from beginning should be true to consume from beginning in the very first time. Okay, producer connect and Redis client connect. So these 4 lines basically an init and also subscribing to transactions. Okay, and also this specific block consumer.run and each message. So this specific block, each message function will be triggered whenever there is a message consumed for this topic transactions. Okay. Now if you see here what we are doing, we are trying to first parse it because we stored that as a plain string transactions, and we are getting all these fields and just printing. And if you see here, as I mentioned, there are total 3 fraud rules, right? So first fraud rule is last transaction amount. This also can be configurable or real time, it can change also based on the user clearly, right? So for now we can just mention this as if any value transaction amount crosses more than 10,000, then we can actually flag this as a fraud transaction. Okay. And this is the name large transaction detected. If you look at the what exactly this function is doing, it basically sends an event to fraud alerts topic. Okay. Send fraud alert. If you look at the definition, we're trying to get construct the alert object and sending to fraud alerts topic. That's it. We don't need key here for now. That's fine because it randomly just ends up in a different partition as a round robin most probably. Okay. That's it. So this all in all, fraud detection service basically consumes the message from the transactions topic, and if there is a fraud detector, then it will push an event to the fraud alerts topic. That's it. Okay. Now let's cover 2 other fraud rules also. Then I will show you the end-to-end functionality. Now, if you look at the fraud rule number 2, that is multiple transactions in short time. Now, this is a bit tricky. If you see here, these 3 lines will define basically to get the latest 5 transactions timestamps. That's it. Okay. What we are trying to do is we are trying to create another list. Earlier, we just created to store all the transactions information, but this list is basically just to store the timestamp. That's it. Okay, simple. So the same fashion, user colon the actual user ID and transaction timestamps. Over here, if you see, it's just simply transaction, so we will store the entire transaction. But if you look at this one, lpush, this is the key, this is the same one, and we are just storing timestamp value. That's it. We are not storing the entire transaction record. And then later we are trimming. If you see here 0 to 4, meaning we'll store only latest 5 transaction timestamps, just timestamps. Okay. Then after this, what we're trying to do is we'll just get the all the list elements. Lrange will give you, and this notation is nothing but give whatever the size, just give me all the elements in the list. If you look at these 2 lines, usually at any point of time, the number of elements will be always less than 5. Simple. Less than or equals to 5. Simple. Okay. So if at all the last transactions count is greater than or equals to 5, and also we are just trying to get the first transaction and the last transaction in this 5 timestamp set. So what we're trying to do is we're trying to get only the last 5 transactions, right? With this trimming, always we'll make sure that we'll have only latest 5 transaction timestamps. Simple. This is transaction timestamps, actually just a typo. Okay. So once we get this, what we're trying to do is first transaction is nothing but in this 5, this will be the lowest value basically. Okay. And we are trying to get the timestamp in Unix timestamp notation. Okay. Now we are getting the last transaction time. This is actually the very latest transaction time. And then we are just trying to get the difference in timestamp. If at all, if the difference is less than 30,000, meaning in 30,000 milliseconds, that will be 30 seconds, right? So if at all, if the difference between the first transaction and last transaction out of the very last 5 transactions set, if the difference is less than 30 seconds, so at any point of time, if more than 5 transactions happen within a duration of 30 seconds, then we can flag this as rapid transaction. Okay, simple. I'll just reiterate. So this specific rule in simple terms, if there are more than 5 transactions happened in a duration of less than 30 seconds, we will identify it as a fraud and we can name that as multiple rapid transactions detected. Simple. Okay, that's the idea of it, this small logic over here. And then the third fraud rule is basically if the location has been changed. Let's say for all the 10 transactions you are using India, but all of a sudden if you observe a transaction happen from some other country apart from India, then you can raise this as a unusual location change detected. Simple. Okay, what you are trying to do, we are using another simple key value. Okay, and the type is basically string. What we are doing is we are storing in this notation user ID colon location. This is the key, right? And the value would be simply the location key. That's it over here. So what we are trying to do is first we are trying to get if there is any last location set for this user ID. If we have this one and the last location and the current time and the current transactions location. Over here, if you see, we are extracting location. So the last transaction, if it exists in Redis, and the current transactions location, if both are not same, then we are raising it as unusual location change detected. Simple. And later at the end, we are trying to basically set this specific transactions location as last location with this line, set location key location. That's it. Okay, again, this is not actually the real world use case, but we can actually have this as a base logic for unusual location change detected. And if you look at this comment, so what we are trying to convey is, overall, after this fraud detection, basically the transaction successful state or rejection state can happen in two ways. One, if you see, based on this, we can send another event to transaction service stating that this transaction is all good, you can proceed ahead and process the transaction. That is kind of an asynchronous way. There can be another one, the transaction can happen, but we can raise it as an alarm. Customer can also reach out based on the alert they receive. Okay, both ways. I'll just leave it up because it's purely depends on the business logic and use, and it can vary per user level as well, right? And this function, as I clearly mentioned, if we received, we'll just fire an event to fraud alerts topic. Simple. Okay, now I'll just cover the other service, the last service, that is alert service. That's simple. We'll just try to consume over here. These are all basically the basic steps. Kafka, and here the client ID is basically fraud alert consumer. That's it. Okay, we are trying to get the consumer instance with this group ID as with this consumer group ID as fraud alert group. That's it. Okay, then consumer.connect as an initial step. Then we are trying to subscribe to fraud alerts topic. That's it. Okay, then for each message received in this fraud alerts topic, we can basically integrate with email, SMS, notification system if needed over here as a to do, but for now I'm just printing over here. Simple. Okay, now let's spin fraud detection service and alert service. Now let's use Wave for that, and over here we'll start first service as node fraud detection service. Okay, first time it will create an error because as there is no group coordinator, but immediately it realized and corrected consumer has joined the group. This also we can verify simply from the Kafka UI itself. If you jump back to the Kafka UI, on the consumer side, if you see fraud detection group, this is the consumer group we provided. Now let's run this one, alert service. Oh, it's alert service. It came from a history node alert service. That's it. All right, now let's look at the Kafka UI one more time. On the topics, on the fraud alerts, we can see the consumer now fraud alert group. Okay, which is consuming from the fraud alerts topic. Simple. Okay, now let's look at the topics. Overall, we have 0 messages in the fraud alerts, transactions is 1. Now the very easy way to trigger one alert is basically if we just increase the amount to more than 10,000. So let's just change this to 10,001 and send. All right, now if you look at the logs over here, on the left side, this terminal is basically fraud detection service. So the first log, if you see, processing transaction, and we have this logic fraud detection of rule number 1, where if the amount is greater than 10,000. If you see here, we are sending an alert, fraud alert sent, large transaction detected. That is the reason. And also on the right side, if you see, it basically consumed from fraud alerts topic, and we are just printing the same record over here. And if you can verify this transaction also, F995 from the postman, if you see F995. Simple. Now let's look at the Kafka UI one more time, and if you can just refresh fraud alerts, if you can see number of messages is 1, and that message, if you try to read it, the reason is large transaction detected. Simple. Okay, and over here in the transactions also, total we triggered 2, right? And messages only 2 messages. Now let's look at the Redis side. If we refresh over here, total we have 3 key value pairs. First one is, we already discussed, user U01 transactions, where we store all the 3 transactions. So there's a refresh button over here. If you refresh, you can see these 2. And now if you look at the timestamp, it's very important. If you see here 170458, now this is 171946. See, so it's not like an array, it's like a list. And when you call this lpush function, basically we'll try to add the element in the left side of it. So from all the list will read from left to right, and when you do lpush, the element will be inserted at the very most left side of it. So the recent transaction will be always be at 0, and the old transaction will always be at the highest value, and we are using ltrim. I'll showcase that also, but this is how the list is working. Okay, this is how the list works in Redis. And also if you see list transaction times total, we have only one. I think we started it later. This you can ignore because the earlier we didn't start the other service, that's why this thing got messed up. That's okay. And user location, if you see for this u01, that is IN. Now let's start with the other small case. That would be, let's change the user u01 to maybe u05. Okay, now let's just send one request. Now if you see for this also the amount is more than 10,000, so we should be getting logs. So first look at the terminal. If you see fraud alert send for the user u05, large transaction detected, transaction ID is 6681. Let's verify from Postman also 6681, simple. And we also received the same on the alert service. So you can assume this as we have sent SMS, email, what are the mode of transport we need to send in the banking application. Simple. Okay, now let's look at the Kafka and Redis one more time. Over here, see, we got the different partition, I believe u04. Yeah, it, so this specific message came in partition 2. Okay, 6681, simple. And if you look at the fraud alerts also, we now have two messages, one for the u01 older one, and if the other one came in partition 3, and that is u05, user ID 05, simple. Okay, now we can do one more thing. Let's send some more requests, so that will trigger rapid transaction. And also I believe, and also I added the difference over here when you're trying to check that if it reaches more than 5 transactions, right? So now let's just push some more requests with u05 only, with a smaller amount, maybe it's just simple as 1000. Okay, now let's send 1, 2, 3, and maybe 4 overall. Now let's look at the logs one more time. And if you see here, we have this difference 85,230. So overall we sent 5 messages, I believe. Let's check that simply from Kafka itself. Transactions, messages, u05. Total if you see, we have 5 transactions. Okay, now let's look at the Redis also. If we just refresh, if you see, now we have total 6, because for every user we are maintaining 3 key value pairs. One is the location, one is the whole transactions history, and the other one is only latest 5 transactions. Again, whole transactions as in only the very latest 10 transactions, whole transaction records. And this transaction timestamp is simply we're storing the very latest 5 transaction timestamps. That's it. Okay, now if you see here u05, we should be having total 5. Okay, now let's push one another message. Okay, now we got the new one. Now let's look at the refresh over here. Okay, now the value changed. If you look at over here, messages u05, total we have 6. However, as we are trimming it out, for the transaction timestamps we have only 5 at any point of time. Okay, now let's look at the logs and see what is the difference between the first one and the last one. Okay, this is basically the very latest transaction, this is the oldest transaction in the subset of the latest 5 elements. Okay, simple. Now let's look at the terminal. The difference is 58,000, that is in milliseconds. So let's send one request one more, and the difference is 98. Now let's send quickly 3 transactions. I sent 46, maybe one another one. Okay, if you see here, the difference is 7 seconds only out of the verify. We'll verify this as well. Now we send, as the time difference is less than 30,000, that is 30 seconds. This is 7.4 seconds, right? We received multiple, we basically triggered multiple rapid transactions detected. Simple. And on the other side also, fraud alert received, right? u05, multiple rapid transactions detected. With this transaction, the very 5th transaction is 25279. If you look at the comparison, 25279, simple. Alright, now simply look at the Redis to just do some simple math to verify this as well. Okay, if you just refresh, now if you see here, the very latest is 172526 and the other one is 172518. By simply looking at this, if you see the series 172518, 2522, 2522 again, 23, 2526. Now visually also, if you just simply see, now the difference is hardly like 7 seconds, right? 2526, 2518. So we received 5 transactions less than 30 seconds, right? And we just triggered this rapid transactions fraud. Simple. Okay, now As we covered two fraud alerts, now let's just simply change the location. If you look at the Redis over here, for user 2, for user 05 location over here, the value is IN. Now let's just simply change this to US maybe. Okay. If we just send, if we refresh for this one, see the value is US. And if you can guess, we should receive unusual location changed alert also. Now let's look at the logs. Okay, now we can also compare that as well. That also, like the transaction ID is 5A4D. If you look at the alert, we received fraud alerts and unusual location change detected, because earlier it was all India. Now we just switched to US and it detected this. And also if you see, the transaction is 5A4D. And on the alert service also, fraud alert received for the user ID, unusual location changes, and the transaction ID is at the end 5A40. Simple. That's pretty much it. And just like that, we built a real-time fraud detection system using Kafka and Redis. With this setup, you can now scale your fraud detection pipeline, store alerts in a database, or integrate with an AI model for more advanced detection. I hope you found this video helpful. If so, please make sure you hit that like button and subscribe, and feel free to drop a comment and share your thoughts about other fraud detection rules that we can incorporate. That's all for this video. Thank you so much for watching, and I'll see you in the next one.